So dear students, this is set 1 of 1 mark questions. The first question is the functions phi1 of x equal to x and phi2 of x equal to x e power x are linearly dash. So we have to find whether they are linearly independent or dependent. So in order to do that, we have to first find the Wronskian of these two functions. If the Wronskian of phi1 comma phi2 is equal to 0, then the two functions are linearly independent. But if Wronskian of phi1 comma phi2 is not equal to 0, then they are linearly dependent. So let us first find the Wronskian and check these conditions. The Wronskian of phi1 comma phi2 is given by the formula determinant of phi1, phi2, phi1 dash and phi2 dash. So that is equal to determinant of phi1 is x, phi2 is x e power x, and phi1 dash is the differentiation of phi1, which is 1, and phi2 dash is the differentiation of x e power x, which we have to carry out by UV method. So it will be x e power x plus, now we will differentiate x, which is 1. So differentiation of x is 1 and e power x comes here. Okay, now we have to find the determinant of this. So the determinant of this will be this x multiplied with x e power x plus e power x minus 1 into this, so x e power x. And so this is equal to x squared e power x plus x e power x minus x e power x. So these two terms gets cancelled, and so we get this is equal to x squared e power x, which is not equal to 0. So therefore the Wronskian of phi1 comma phi2 is not equal to 0, which implies that the functions phi1 and phi2 are linearly independent. And so the answer here is linearly independent. So these two functions are linearly independent. Now we shall solve another question. The Wronskian of phi1 of x equal to e power x cos x and phi2 of x equal to e power x sin x is dash. So we have to find the Wronskian of these two functions, and as we saw before, we are going to use the same formula. So Wronskian of phi1 comma phi2 will be equal to determinant of, so first is phi1, so e power x cos x, and then phi2, so e power x sin x. And then here we have the differentiation of phi1. So it will be, so first we will differentiate cos x, which is minus sin x, so minus e power x sin x plus e power x cos x. And then the differentiation of the next term, that is this for e power x. For sin x the differentiation is cos x, so e power x cos x plus e power x sin x. So we have done it by UV method, and after this we have to find the determinant of these values. So that will be equal to e power x cos x multiplied with e power x cos x plus e power x sin x, and then minus this into this. So e power x sin x multiplied with minus e power x sin x plus e power x cos x. And so here we could take e power x common throughout. So this will be e power x multiplied with e power x, and when cos is multiplied inside, so we get cos squared x plus cos x sin x. So similarly we have, so this minus, again these two e power x, when it comes common out, so it becomes e power x multiplied with e power x, and the sin x, when it goes inside, it becomes minus sin squared x plus sin x cos x. So we shall simplify this furthermore. So When we simplify, we get this is equal to, so I will write it here. So e power x into e power x is e power 2x, and it is common both in both of these places. So we can take it common outside. So e power 2x multiplied with cos squared x plus cos x sin x. And then minus into minus is plus sine squared x, and then plus into minus is minus sine x cos x. So we see that these two terms gets cancelled and we get sine squared x plus cos squared x, which is 1, and so the Wronskian is e power 2x. So this is the answer, and so therefore the Wronskian of these two given functions is e power 2x. Hope you have understood these two problems. Thank you.